of wagons. Each wagon is called a monomial. You notice that I did not write monomial here. You will know why in a minute. Now, a monomial, which is the one wagon, a monomial is made up of numbers, which we call coefficients, and variables. Each number and variable, they are linked together by the operation multiplication. So you're going to see numbers that are coefficients, they belong to set R, and you're going to see certain variables. And these variables are to the exponent of the natural number n. All of these exponents are from the set n. They cannot be negative numbers, and they cannot be rational numbers, يعني fractions, and they cannot be irrational numbers, يعني square roots. So this is why I did not write monomials, because they are not included in the polynomial. So now, a monomial is a wagon which is made up of numbers, or we call them coefficients of the variable from the set R, variables of exponents that belong to the set n. And the variables and the coefficients are linked with the operation multiplication. Now, these monomials are linked together with the operation addition or subtraction. And together, all these wagons form the polynomial. Each wagon is a monomial. Every two are the binomial. Every three are called the trinomial. And more wagons will give you the polynomial, many monomials. P of x is of the form coefficient of x. Okay, so x is the variable we're using. Coefficient of x to the degree, 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 x is 0. So here is 0, here is 1, 3, and 2. X to the 0 is 1. This is why you call this the constant. Constant because x to the 0 is 1. Now, write P of x in descending order. Descending means from the highest exponent to the lowest. And then write its degree. So P of x is equal to 5x cubed plus 3x squared minus 3 over 4x plus 7. Now, the variable here is x, and the highest exponent or degree, this polynomial is of degree 3. We come to number 2. We say that P of x is equal to Q of x, which is another function, another polynomial, if and only if they have the same degree. And the coefficients of like terms, x cubed, x squared, are equal in both. 2, x cubed, 4, x squared, 5. Constant 5. Here you have 0x. I put here 0x because I don't have here an x. I just wanted to tell you that if you don't have an x here, okay, you need also not to have an x of degree 1 in the second one. So you represent it as 0x because 0 times x is 0. So when two polynomials are said to be equal, it means that they have the same degree to start with, and then coefficients, and coefficients the same. Zero polynomial is the polynomial whose coefficients are 0. So x squared, let's say if we started with x squared, it has coefficient 0, x1 0, and the constant is 0. Adding zeros all together, you're going to have a polynomial equal to 0. When x is equal to 5 is said to be a root, then p of x, so x equals 5 is said to be the root of p of x, then p of 5 is 0. So I'm going to experiment on this one. opposite the 2. Now, is this equal to 0? I'm checking. 4 plus 8 plus 4 is not 0. So, x equals to 2 is not a root. What is a root of this polynomial? P of minus 2. Let us check it. P of minus 2 is equal to 4 minus 8 plus 4. Is this equal to 0?
Yes.
So this is, so x equals minus 2 is a root of P of x. So the aim here to show that if a number you replace it instead of the variable gives you the polynomial equal to 0, then we call this number a root. Operations with polynomials: addition, subtraction, multiplication, and division. You can add two polynomials, it will give you another polynomial, and the degree of the polynomial stays the same. You can subtract polynomials and also you will get a polynomial. You can multiply two polynomials and the degree of the polynomial will be the sum of the two polynomials. And you can divide polynomials and the division will be the degree of the polynomial from this division will be the subtraction of the degree of the two polynomials. So as a summary, the polynomial is a set of monomials linked together with addition or subtraction operation. Each term is called a monomial, which is the wagon, which is made up of variables and numbers such that they are combined together with the multiplication operation. The numbers below